We have looked at solving radical equations in a previous unit. Now we're going to extend it to not just solve any radical equation, but radical equations either written in radical or exponential form. So a couple things to remember that we've talked about before. A radical equation is an equation with a variable under a radical. And if we want to solve a radical equation, we will isolate the radical on one side and square both sides. I'm going to extend on that and say raise both sides to the same power. So it may be a power of 2 with squaring, or it may be a power of something else. We also have to make sure and check for extraneous solutions. So solutions that show up but don't really work. Specifically if we have a variable raised to a power. So let's go ahead and look at 3 examples. They are slightly different, so do please make sure and watch all 3. In the first one, I want to solve this, so I'm going to start by isolating the radical, so I'm going to add 3 to both sides. And I will have radical x plus 2 equals 2x plus 3. Now I want to get rid of that radical, so I'm going to go ahead, since it's a square root, technically it has an index of 2, I'm going to go ahead and raise both sides to a power of 2, and I'm going to do it to this whole side here. It's very important that I do it to the entire right side and recognize that a binomial squared I'm going to have to FOIL. So my radical and square cancel, leaving me with x plus 2 over on the left equals, and then I write this twice, 2x plus 3 times 2x plus 3. Since the purpose of this video is not to learn the FOIL process, I'm going to go ahead and give you the answer for this after foiling. It gets 4x squared plus 12x plus 9. You should already know that. You should be coming into that video with that prior knowledge. So if you are unclear of how I got that, please be sure and talk to me. Now I notice that because of this square here, that's my highest degree, so it's going to dictate what type of equation I have, meaning I have a quadratic equation. I know in order to solve a quadratic equation with both a quadratic and a linear term, I need to get in standard form first. So I'm going to subtract the x and subtract the 2 and get 0 equals 4x squared plus 11x plus 7. Now I'm going to go ahead and do some practice with my previous objectives, because I'm going to have to now solve this quadratic equation. This doesn't look like something I want to try to factor, so I'm going to go ahead and jump to my quadratic formula. And I'm going to say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Once again, the purpose of this video is not to demonstrate how to use the quadratic formula, so I'm going to go ahead and give you the result after solving. After simplifying my formula, I get negative 11 plus or minus 3 all over 8, which simplifies to then be x equals negative 1 or negative 7 over 4. Please make sure you are talking to me in class if you are saying I could not get from here to here, or I could not get from here to here. Now from here, because extraneous solutions can occur if a variable is raised to a power, and I raised a variable to a power right here, this had just been an x and I changed it to x squared, I'm going to have to check both of these. I will check them by putting them back into my original equation. So first I'll check negative 1. And I'm going to ask myself, does the square root of negative 1 plus 2 minus 3 actually equal 2 times negative 1? And I'm also going to ask myself, does the square root of negative 7 over 4 plus 2 minus 3 actually equal 2 times negative 7 over 4? Again, I'm going to skip some of my steps in my solving process, but this here comes down to be square root of 1 minus 3. Does it in fact equal negative 2? So does 1 minus 3 equal negative 2? It does, so that is going to work. So negative 1 is going to be one of my solutions. Checking over here, this is going to become the square root of 1 over 4 minus 3. Does it equal negative 7 over 2? Well, the square root of 1 over 4, I can take the square root of both top and bottom, and I get 1/2 minus 3 is the same thing as 6 over 2. Does that equal negative 7 over 2? Well, I know that 1/2 minus 6/2 is going to be negative 5/2, so it does not equal negative 7 over 2. So I'm going to go ahead and cross that out as one of my solutions, leaving me with only one true solution. Another thing we talked about back when we started talking about radical equations is that, this was what we talked about this unit, that exponent form is just another way of writing a radical expression. So we'll use the same steps if we have an exponent as opposed to a radical. But instead of squaring both sides, we're going to raise both sides to the same power. That power is going to be the reciprocal of my given exponent. So like before, I will start by isolating my radical or my exponential expression. So I'm going to divide both sides by 2 to get that by itself, and I'll have x minus 2 to the 2/3 power equals 25. And then I'm going to go ahead and say, how can I get rid of a power of 2 over 3? Well, if I have a power to a power, remember that we multiply when we have a power to a power, and I can do anything as long as I do it to both sides. So if I raise this side to 3 over 2, 2/3 raised to the 3/2 would be 6 over 6, or 1. So it would indeed make my power drop out, leaving me with just x minus 2. However, if I raise the left side to 3 over 2, I have to do the same to the right side. Remember, a power of 3 over 2, as you saw in Objective 1, is the same thing as taking the square root of 25 cubed. And I can either do the radical or the cube first. Since I know that the radical of 25 is 5, I'm going to go ahead and change this to be 5 cubed, or x minus 2 equals 125. Adding 2 to both sides, I get x equals 127. And if I wanted to check my result, I would plug that back into my original equation. To keep this video from getting too long, I'm not going to check this one. I'll let you go ahead and do that on your own, though. It does work out. I did check it, just not in the video. Finally, the last example, I also want to bring to your attention that we ran into a situation before where we would have two radical expressions. We're going to see that happen again. We'll either have two radicals or possibly two terms with rational exponents. What we'll do when that occurs is we will isolate one of our radicals or one of our terms. Then we will raise, and this is worded kind of funny, so I'm going to talk a little bit more with this in terms of this specific problem. So first thing I do on this problem is I want to isolate one of my radical expressions. Well, I already have them isolated. I actually already have one of them on this side and one of them on this side. So I'm going to go ahead and say 2x plus 1 to the 0.5 is 2x plus 1 to the 1/2. And 3x plus 4 to the 0.25 is the same thing as 3x plus 4 to the 1/4. So now, if I wanted to get rid of this 1/2 exponent, as we just saw in the previous example, I could raise it to the power of 2. But if I raised this side to the power of 2, 2 times 1/4 would be 1/2. So I would still have that exponential, that fractional exponential piece. I don't really want that. If I looked at how I could get rid of the lower power, I could raise that to the power of 4. Notice that raising this side here to the power of 4 would indeed get rid of that fraction. So I'm going to go ahead and do that. I'm going to raise both sides to the power of 4. To the 4, to the 4. Doing that is going to leave me with 2x plus 1 squared equals 3x plus 4. Again, I'm going to recognize that that means write that twice in FOIL, giving me 4x squared plus 4x plus 1 equals 3x plus 4. I notice that I'm quadratic, and I do have both a quadratic and a linear term, so I want to get everything on one side, get it in standard form or equal to 0, so I'm going to subtract 3x and subtract 4, giving me 4x squared plus x minus 3 equals 0. Again, I don't want to try to factor this, so I'm going to go ahead and use my quadratic equation, and I'm going to get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I am not working these quadratic equations out, but I do encourage you to do so in your notes to get that extra practice and just to do it as a check-in to make sure that you are getting the same answer as me. So I get negative 1 plus or minus the square root of 49 over 8, which after reducing gives me an x value of negative 1 or 3 over 4. Again, because at some point I squared a variable, I am going to have to go ahead and check my solution. So I'll check it by plugging it back into my original equation. So I'm going to ask myself, is 2 times negative 1 plus 1 to the 1/2 power the same thing as 3 times negative 1 plus 4 to the 1/4 power? Well, this is going to give me negative 1 to the 1/2. And as soon as I see this, so negative 2 plus 1 is negative 1, I realize that raising negative 1 to the 1/2 power is the same thing as taking the square root of negative 1, which is going to give me an imaginary number. So I'm going to go ahead and say x does not equal negative 1, and I'm just going to check 3 over 4. Plugging in 3 over 4, I get 2 times 3 over 4 plus 1 to the 1/2. Does it equal 3 times 3 over 4 plus 4 to the 1/4? After working this out, I get 5 over 2 to the 1/2. Does it equal 25 over 4 to the 1/4? Well, keep in mind that I can break this into multiplication and raise it, do a double power, because power to the power is multiplying. So, don't think I have any more room. There we go. I'm going to do one last thing and say that 5 over 2 to the 1/2, is it the same thing as 25 over 4 to the 1/2 raised to the 1/2 power again? Why can I do that? Because 1/2 times 1/2 is 1/4. If I then do this inner 1/2, I get on my right hand side 1/2, 25 to the 1/2 is 5, 4 to the 1/2 is 2. I still have this outside 1/2, so notice my left side does equal my right side. That's me doing it without a calculator. You could also at this point have put this into your calculator and approximated, as well as put this side into your calculator and approximated and checked, do my two sides truly equal one another? That then will be my only solution. The only thing I want to remind you of before I stop this video is just don't forget that if you have extraneous solutions, that you make it clear which is extraneous and which is not. So when I'm looking over your work, I'm not trying to guess if you're giving me an answer that is extraneous or is an answer that is truly an answer to your problem. And that's it.